Hello guys, hope you are doing well. So today we are going to discuss about a problem known as best time to buy and sell stock, which is the lead code question number 121. The stock questions are one of the favorite questions in the interviews nowadays, and I'm sure many of them would face this. So initially we would start with the easy questions, and in the next videos I'll talk about the various types of stock questions which are the medium and hard difficulty. So let's read the problem statement. So it says if you were given only if you were only permitted to complete at most one transaction, that is buy one and sell one share of stock, design an algorithm to find the maximum profit. So the main thing we need to focus here is at most one transaction. So considering the input value, which is 715364, the maximum profit we could get is by buying the share at day 2 at price 1 and sell it on day 5, and so the total profit would be 6 minus 1 equal to 5. And if we consider the second example, there is only downward trend in this input, so there is no point in purchasing a stock and then selling it, because it would anyways lead to a loss at any point of time. So let's try to visualize it so we can know the, some pattern going on in this question. So I'll draw a graph here, marking the points. 6 and 4. Okay, so I'll mark the downward trend by a red line. And the upward trend by a green line. So we want to find the maximum profit. So how could we get it? We can only get it by taking the upward trends, which is from this point, to this point, and from this point to this point. But since only one transaction, we are only allowed to do one transaction, we need to purchase the share at this point, okay, and share it and sell it at this point, so we would get the maximum profit. So the one of the approach you might have think initially is selecting each and every point and calculating the profit. And since sell can be only done after we purchase the share, so if we are selecting this point in the case of brute force solution, then we need to go to this point, this point, this point, and then this point. Similarly, after selecting the second point, we would start here and go and calculate the profit at this point and this point, and at this point we would get the maximum profit. Okay, uh, now there is not a wrong solution, but the time complexity for a brute force solution uh, would be big O of n square, since we need to go through each and every point and calculate the profit which we would get at each and every point. So how can we do at uh, linear time complexity? The thing to note as here is that we can store the minimum value at each and every point. So the minimum value would be stored at this point, and we'll calculate the profit at each and every moving forward point and would sell the share here. So let's write the algorithm. So it would go like this. So initially we need two variables to store the minimum value and the maximum value, as we saw. So and minimum equal to maybe you can consider it at the first point, okay, and the maximum value as well, the maximum profit. Okay, so the profit would be 0 initially, okay, and then we'll write a for loop. Okay, starting the for loop, since we need to iterate through each and every point, going from and I equal to 0 price, taking the length of the array and iterating through it. Okay, now what would be the condition which would help us to reach our optimized goal? So it would be like, first we need to check whether the current value is greater than, is it greater than the minimum value which is stored here, which is the minimum, that would be the point where we would purchase the share, or is it greater than that? So if it's lower than that, so if the current value, which is prices of at I, is smaller than minimum value, we would store it here. Okay, so mat dot minimum of this and prices of I. Okay, oh no, so it's not required since we only need to store the value, so this would suffice our requirements. And if the current value is greater than the minimum value, so we can sell the share at that point. So we need to go into the else condition, which would help us to know that whether the profit which we are getting at the current point is greater than the previous profit or not. So here we need to do mat.max, and this would be the max value which we are storing, and the other would be, so we need to calculate uh, the profit, right? So it would be the price at current point minus the minimum value at which we would have purchased the share, and this is the final profit, and at the end of the program we would return the final profit. Let's try and run this program. Oh, sorry, it should be less than prices dot length. Apologies. Oh, sorry, it's profit here, right? This happens when you are not concentrating on it. Okay, so what's the issue? What's the output? Okay, so the profit, prices of I minus minimum. Okay, if prices of I is not greater, it should be smaller, right? This should work fine now. I hope so. Let's test it for the second test case. Oh, it did work. I'll try submitting the put. Oh, we need to check whether the input is, whether there is no input value. So if prices dot length equal to 0, return 0, right? And or we can always put one more condition. If even if the length is 1, we should return 0, since if there is only one input value, we can't buy and then sell the share, right? So yeah, let's submit it. Perfect. So it's better than the 98.56% of Java online submissions, and the memory usage is, so I would write the space and time complexity is right here. So the time complexity complexity is big O of n, since I need to iterate for each and every element, and the space complexity, since we are only using two variables here, so the space complexity is linear, and which is sorry, it's constant space complexity, so which is this. So yeah, I hope I was able to explain you the whole problem. If you have any questions, you can ask me down below, and I'll definitely try to clear your problem. Thank you.